You've probably used a thermometer to measure temperature at some point, but how do you know that that reading is the real temperature? This is where temperature calibration comes in. In order to ensure that temperature measuring devices are providing accurate readings, they must be calibrated periodically. To do this, a technician will compare the reading of the unit under test, or UUT, to the reading of a more accurate and calibrated sensor, often called a reference or standard, across a number of different temperature points. Calibration procedures will vary by industry, but a general rule of thumb is to use a reference that is at least 4 times as accurate as the UUT. This specific test uncertainty ratio is often referred to as a 4-to-1 calibration. But you may still be wondering, how do you calibrate a reference? These high-accuracy measurement devices need to be sent to a temperature calibration laboratory, where they will be calibrated against intrinsic physical properties of nature in controlled conditions for maximum accuracy and repeatability. This is referred to as a primary calibration. By using these intrinsic standards, primary calibrations can remain in compliance with the 4-to-1 calibration rule, despite the increasing accuracy requirements of the unit under test. Calibrations for lower accuracy temperature devices are often performed in the field, using a portable reference and temperature source. Using a device that received a primary calibration as a reference is known as a secondary calibration. After comparing the readings of the UUT and the reference across multiple temperature set points, the UUT will either pass calibration and remain in service, or fail and need to be adjusted or replaced. In both cases, calibration reports should be generated for the completed tests, detailing the calibration process, results, and adjustments made. This allows for quality control and compliance across an organization's entire range of temperature measurement devices. These reports also establish traceability to a governing national or international body, such as NIST or other national metrology institutes recognized by the International Committee for Weights and Measures. We hope you enjoyed this introduction to the world of temperature calibration. In the next video, we'll go over some of the measurement devices that you'll encounter within the industry. We also recommend watching part 2 of our pressure calibration series, which covers some of the key terminology that you'll come across within the calibration industry.